Hey there, my fellow intellectuals. Dr. Kyle here with another video, and we're back with another problem on dimensional analysis. It looks very similar to the one that we just did because it involves the drag force, except this time we are going to be looking at the drag force on a non-viscous fluid and determining how the drag force depends on some other quantities because that differs from a fluid with actual viscosity. So this problem is asking, how does the drag force of a non-viscous fluid depend on the density of the fluid ρ, the radius r, and the speed v? And we have to figure out which of these five quantities is the drag force proportional to. So same idea from before, just that instead of viscosity, we're now dealing with a non-viscous fluid. And so the drag force will depend on the density. And so we're going to have to do basically the same thing we did before, writing out all of the different variables, determining their units, and setting them equal to the units of the drag force. So if you saw the previous video, I won't go through this again, but I will just mention that if you saw the previous video on drag force has units, as does any force, has units of mLt to the minus 2. That is standing for mass, length, and time. And so we need to have some combination of ρ, r, and v that gives us the combination of mLt to the minus 2, mass, length, and time to the minus 2 power. So again, what are the units we have, or the quantities we have to play with here? So we have density. The density, if you remember, is a mass, so we have an m, over a volume. But volume has dimensions of length cubed, right? So really, I'm going to write this as L cubed, just to say that it's a mass over a length cubed. Now, radius has units of just 1 power of length. Velocity has the units of length divided by time. And again, we need to combine all of these three variables into something that has the units mLt to the minus 2. So we're going to write ρ to the alpha, r to the beta, and v to the gamma. I actually wrote alpha this time. I wrote alpha as alpha, beta, gamma. Gamma. I didn't remember my Greek alphabet there, but I wrote alpha as gamma last time. And so we need to have all of these units come out to something that looks like mLt to the minus 2. And so we're going to go term by term here. So we can see that ρ is equal to m over L cubed. So if we raise ρ to the alpha power, we should have m L cubed raised to the alpha power. That just comes from the ρ. The r to the beta should give us an L to the beta. And then the v to the gamma should give us a L over t to the gamma. And this should all equal mLt to the minus 2. I know I sound like a broken record, but I think just repeatedly saying that will help drive the point home. And now we have to play the game of matching things on the left and the right side. So first off, I should also just say this is m to the 1, L to the 1. I know that is kind of obvious, but maybe it'll just help us when we're doing the algebra. So bringing this term down here, we have m alpha, L to the negative 3 alpha. This term gives us L to the beta. This term gives us L to the gamma, t to the negative gamma, and this equals, again, m to the 1, L to the 1, t to the minus 2. And so what we have to do here, again, is do some matching. So again, let's notice we have a m here, m here. It's the only m term, the only mass term that comes up on both sides of the equation. So we can already establish from that alpha has to equal 1. Lovely, so we've already gotten that out of the way. Now we have 3 terms with L. Notice we have 1, 2, 3 terms of L on the left side, and this all needs to equal power of 1. So what we're going to write here is negative 3 alpha. I'm just going to write down the powers now, plus beta plus gamma is equal to 1. Okay, and then lastly, let me get a different color here. I'll just use white. We're going to say that t to the minus gamma and t to the minus 2 have to be equal. So all that says is that negative gamma has to equal negative 2. We can establish now that gamma has to equal positive 2. And great, we have 2 of our 3 unknowns. So we have alpha, we have gamma. The last one we need is beta, but we can just plug in the value of alpha and gamma into these equations, right? So we can plug in alpha here, and we can plug in gamma there. And what do we get? So we'll get negative 3 times 1 plus beta. Now gamma is 2, so that's plus 2 is equal to 1. We have negative 3, so we have a negative 3 plus a 2 plus beta is equal to 1. Negative 3 plus 2 is a negative 1. Negative 1 plus beta is equal to 1. And if I do my algebra correctly, that should say beta is equal to 2. Okay, so let's circle that. So what do we have here? We have alpha is equal to 1, beta is equal to 2, gamma is equal to 2. So what did I actually assign to all of these? It was rho alpha, r to the beta, v to the gamma. So I'll just write that again. Rho to the alpha, I'm already forgetting. It was r to the beta, and then v to the gamma. And so plugging in our values for alpha, beta, and gamma, we should have rho to the 1, r to the, what was r? r is our beta, right? So beta is 2, and then gamma is also 2. So that's rho to the 1, r squared, and then v squared. So this must be proportional to the drag force. That's the thing we were looking for in the first place. And so if we look back up at our multiple choice answers, we're looking for something that has rho to the 1, r to the 2, v to the 2. And if you look at our 5 choices, that has to be choice E, because this perfectly has rho r squared v squared. So this is our answer, and this is what the drag force must be proportional to. So I hope that, again, demonstrates the power of dimensional analysis. This is another example that we worked through together that I hopefully will benefit your learning process. And if you have any questions, of course, leave a comment below in the video. Give the video a comment and a like if you thought it was useful. Also consider hitting the subscribe button. Love getting new viewers to the channel, and I like to educate and just share what I know about physics to those of you who want to learn more about physics. And with that, I will conclude the video. So tune in next time.